Kidneys remove the metabolic waste from the liquid part of the body, meaning the liquid part of the body. Plasma. The process that involves removing metabolic waste from the body. Excretion. It shows the kidney tubular and its associated blood vessels. Describe the functions of the regions labeled A and B. A. Ultrafiltrations. Small molecules from blood or gallbladders into bone mass renal capture. A force push out under the high pressure. B. Selective reabsorption back into the blood capillaries, for example, of any substance that is filtered or reabsorbed. The table shows the concentrations of some substance in the blood at X, the fluids at Y, and the urine at Z. Name the substance shown that has molecules that are too large to pass through the walls of capillaries. Look at the table first. Protein. It's all reabsorbed in the kidney. Glucose. It's a metabolic waste product. Urea. Explain why concentrations of sodium ions and urea are greater at Z than at Y. Water has been reabsorbed by osmosis by collecting dark nephrons, proximal convoluted tubular. Either that by that there is no change in sodium ions urea solutes, but volume of water is less. People who have acute kidney failure are given dialysis treatment. In dialysis machines, the blood flows through narrow tubes made from partially permeable membranes surrounded by dialysis fluid. Dialysis fluid contains sodium ions. Use the information to suggest the concentrations of sodium ions that should be in the fluid and give a reason for your answer. 0.35 gram per 100 centigram. Same concentrations as the blood to be in equilibrium with the blood to prevent loss or gains of sodium ions. Prevents reduced osmosis. Any fecal greater than 0 less than 0.35 gram per 100 centigram. Excess sodium salt in the blood, diffusion from blood into dialysis fluid. State two components of blood that are not in dialysis fluid. Red blood cells, antichorides, white blood cells, lymphocytes, phagocytes, platelets, thrombocytes, name plasma proteins like fibrinogens, antibodies, name hormones, urea, uric acid, amino acids, name vitamins, cholesterol, fats, fatty acid, glycerol, bacteria, virus. Heparin is added to the blood before it returns to the body from the dialysis machine. Heparin prevents a person's blood from clotting. Describe the process of blood clotting. Reference to platelets and correct contents of clotting. Fibrinogens converted to fibrin, soluble to insoluble. Fibrin is insoluble. Thrombin enzyme in contact, mesh network web to trap blood cells. And then reference to prothrombin or involvement of calcium ions clotting factors. Reference to prothrombins or involvement of clotting factors, calcium ions. Define the term as excretion. Removal from body organism cell. Removal from body organism cell. Poisons, toxins, harmful substance. Name example or waste products of metabolisms, respirations, deaminations, chemical reactions in cells or in the body. Substance in excess of requirements. It shows the kidney tubules and the blood vessels associated with it. The table shows some processes that occur in the kidney. In the table, write the letter of the part shown in the figure where each process occurs. You must put one letter in each spot. You may use the same letter more than once. Process filtrations of blood is H. And then reabsorptions of most of the solutes in the filtrate is C. And then water is absorbed by osmosis to determine the concentrations of urine, G. Unfiltered blood returns to the renal vein, DRE. Your table lists the components of blood filtrate and urine. Complete the table by using ticks and crosses to show whether or not each component is present in a filtrate and in urine of a healthy person. The first component has been done. Red blood cell, no. White blood cells, no. Plasma proteins, no. Glucose, yes, infiltrate, no in urines. Urea, yes, infiltrate and in urines. Salts, yes, infiltrate and in urine. Water, yes, infiltrate and in urine. A healthy kidney controls the excretions of urea and other waste products of metabolism from the blood. After kidney failure, there are two possible treatments: dialysis or a kidney transplant. It shows how blood and dialysis fluid move through our dialysis machines. Patients pump, blood flow, dialysis fluid, blood, bubble trap. Describe the changes that occur to the blood as it flows through the dialysis machine from A to B. Changes that occur to the blood from A to B. The urea concentrations decrease, and then the water content increase. Salt concentrations decrease. Reference to glucose sugar can be increased, decreased, or stays the same. And then discuss the advantage of kidney transplants compared with dialysis. Long-term solutions, person no longer needs regular dialysis. An example of disadvantage of dialysis: pain, tiring, discomfort, takes a long time, fears eventually. Increased freedom, better quality of life, better, more efficient control of compositions of blood. Can have wider diet. Reference to cost or economic benefit to health service or to individual. Two brothers have to make a difficult decisions. One brother with blood group AB has kidney failure and is on dialysis. The healthy brothers agree to donate one of his kidneys to his brother. He has to have a blood test. The father has blood group A and the mother has blood group B. The brothers have a sister who has blood group O. Explain how this girl has blood group O when the parents have different blood groups. You must use the space below for a genetic diagram to help your answers. Use the symbol IA, IB, and IO to represent the others that involve in the inheritance of the blood group. So it's IA, IO times IB, IO, IO times IB, IO, and then it's IA, IO plus IB, and then it's IO, blood group O. Aligns IO recessive to IA and IB. Pair must both have IO, be heterozygous. The healthy brother can only donate the kidney to his brother if they both have the same blood group. What is the probability that the healthy brother also has blood group AB? 25%. Define the term excretion. Removal from the body organisms, poisons, toxins with products of metabolism, respirations, deaminations, chemical reactions in cell or in the body, substance in excess of requirements. It shows the dialysis tubing for treating people who have kidney failures. Their dialysis fluid is a solution of glucose and salts. Blood vessels, dialysis membrane, blood in, blood out. Dialysis out, dialysis in. Explain how, when the patient is receiving dialysis treatment, the loss of plasma proteins and red blood cells is prevented. Too large to go through the membrane. Pores in the membrane is too small. The normal glucose concentrations of the blood is maintained. Dialysing solutions that contains glucose. Glucose sugar diffuse move and the blood is at the correct normal concentrations. A person with kidney failure receives regular dialysis treatment for 17 days. It shows how the concentrations of urea in the blood change over the 17 days. State how many times the person received dialysis treatments. 9 times. Calculate the decrease in concentrations of urea in the blood from the beginning of dialysis until the end of the treatment. 240 minus 40 is 200. 240 minus 40. Describe the changes that occur in the urea concentrations in the blood over the period shown. You will gain credit for using the data in the figure in your answer. Changes that occur in the urea concentrations in the blood. Decrease during dialysis treatment, time on machine. Increase over the next day until next dialysis. After dialysis, maximum concentrations decrease over time. Minimum concentrations after dialysis decrease over time. Difference between maximum and minimum decrease. Increase after dialysis is last step after day 9 or 10, treatment 5. Any comparative data occurred giving days and urea concentrations. Explain the changes in urea concentrations in the blood as shown in the figure. Increase urea produced in liver, deaminations, amino acids decrease. Diffuse out of blood into dialysis through dialysis membrane. Reference to concentration gradient, no urea in dialysis. For example, diet changes after day 9, treatment 5, last day increase. It shows the kidney turbine and its associated blood vessels. Use label lines and the letters P, Q, and R to identify the areas in the turbine shown in the figure. P is where blood is filtered, Q is where glucose is reabsorbed, R is where the concentrations of urine may be increased by the absorption of water. So, glomerulus is where blood is filtered, and then first convoluted tubi is where blood is reabsorbed, and then collecting duct is where the concentrations of urine may be increased by the reabsorption of water. Water is reabsorbed in the kidney. Explain how water is reabsorbed in the kidney. Osmosis accept diffusions, down the water potential gradients accept high to low. Antidiuretic hormone ADH increase probability of collecting duct walls. Describe what happens to the urine after leaving the kidney turbine at X. Ureter, peristalsis, start in bladder, urethra, urinations, maturation, correct reference to sphincter muscles. Describe the functions of liver in excretions. Deaminations described as amino acids, mix ammonia, ammonia to urea or urea produced. Breakdown of red blood cells, hemoglobin, mixed bowel pigments, appropriate reference to bowel, productions of carbon dioxide in respirations, maximum tool for breakdown of hormones or drugs or alcohols or poisons or hydrogens, parasites.